Hi all. So in this session, we'll talk about software architecture. So, so in the design phase of software development lifecycle, the software architecture is generally defined, okay, and documented. The significant element of software development lifecycle is the software architecture. So software architecture defines fundamental organization of system and more simply defines a structured solution. Okay, it defines how components of software systems are assembled, their relationship and communication between them, uh, and it serves as a blueprint for software application and development basis for development team. Okay, so why we need software architecture? So why should we care about software architecture? Sometimes developer just want to jump right in and start coding. So software architecture is a foundation of software system. Like other types of engineering, the foundation has profound effect on the quality of what is built on the top of it, such as it holds a great deal of importance in terms of successful development and eventually maintenance of system. So software architecture is a series of decisions. Some of the earliest decisions come from designing the architecture, and these carry a high degree of importance because they affect the decision that come after it. So the great size and complexity of software system, the more you will need a well thought out throughout architecture is in order to succeed. Software architecture provides a number of benefits when done properly, which greatly increase the chance that software system will succeed. So, what is the importance of software architecture uh, pattern? Okay, so software architecture holds significant importance for it can solve various problems within different domains. For instance, instead of depending on single server, complex user requests can be easily segmented into small chunks and distributed across multiple servers. In another example, testing protocols can be simplified by dividing various segments of software rather than testing the whole thing at once. Okay, so some here are some reasons why software architecture pattern are important for any software application. So, uh, dif- basic characteristics of an application, defining the basic characteristics of an application. So we have to know the characteristics, strength, weakness, uh, and that becomes important for choosing the right one to meet your business objective. It has been observed that architecture pattern helped define an application basic uh, characteristics, characteristics and behaviors. For example, some architecture pattern can be naturally used for highly scalable application, whereas other can be used for agile application. Okay, so we have to maintain our quality and efficiency. So there is a possibility that any application you build might face quality issues according to your your software development quality attributes. Selecting an architecture pattern can help minimize the quality issues along with maintain efficiency. So it is natural for software application to undergo numerous modification and iteration during software development even after production. So therefore planning a core software where before hand provides agility to the application and make a future modernization effortless. So we have to like we are providing agility, and there is like prior planning and your knowledge of software architecture give a clear idea of how the application and its components will function with the architecture in place. So the development team can adopt the best practice to resolve complex process and solve any errors in the future. So to enhance productivity, irrespective of skills and knowledge one has about programming knowledge, framework, or application. So we have to understand this, characteristics maybe that will help how to build a proper architecture. Okay, so may we know like we have a requirement, and here this part comes software architecture. So once we get the requirement, based on that we will architect the things, and then we will provide developers to do the coding. Okay, so let me go to this next slide. So which we just talk about architecture pattern. So, so architecture pattern, as I said, it is a fundamental architecture for software system. It converts characteristics to a high level structure. So what about design pattern? Where it comes? So this is a specification that could help in implementation of software, and it is the description of all units of software system to support coding. So if you see this diagram, right? So this is like architecture, architecting the things where we need. Well, let's imagine your team given a task to build a house and live in it. So to begin with the task, they would first have to plan it out before placing bricks and cement on an empty ground. So moreover, even after house is planned, they would need basic amenities like kitchen, a bedroom, hall, living room, and all this. So and many more. So in this analogy, how the house should looks uh, represents a architecture pattern. So okay, whereas the interior of the house represents the design pattern. Okay, and so so this is the more we have to before we implement anything, we should have a very good planning, need to good nicely architect, otherwise you will face a lot of problems. So let's say we are building in a house and we don't know the strength of the ground, how many pillars we need, and how like uh, in the first floor, how many that steel we need. So architect plan properly. That's the reason a house will a house will be very strong. So that the same way, when we are building a software, we have to very careful while architecting the things. So we have to understand the requirement, and based on that we need to plan the software. Okay, which design pattern it suits and which architecture it suits. I think we have many architecture patterns: layered architecture, event based architecture, and microservices, and like microservices architecture, and cloud based architecture. So we have many. So we have to understand based on the requirement which suits your your application, means your project. Okay, so so let's say we know the planning. Now we need to uh, draw the flow. What comes first and what comes next, and what so that this is also very important. Okay, so to understand the flow, first of all we have to understand how to uh, draw that flow. So to draw that flow, we need to learn this diagrams, architectural diagrams. So an architectural diagram is a visual representation of all elements that convey software behavior to both technical and non-technical. So good software architecture diagrams are source of truth and clarity. So you want your diagram to quickly convey a software system essential compositions and behavior. Okay, so we have two categories, uh, like diagramming before you start coding and diagramming after your code has been written. So we'll have different benefits for forward design and backward design. So forward design start with requirement analysis and design, then proceed to implementation and testing. So backward design start with the existing software and works backward to understand its structure and structure, design and requirement. Okay, so a good diagram will be diagram have core components, highlight critical systems interactions and relationships, and easy to access, maintain consistent style, make it to identify potential flaws or areas of improvement in the software architecture. Okay, so to draw the diagrams we have to understand flowcharts. So flowcharts, this concept, is part of UML. So UML, I think most of the people know. UML is a unified modeling language, a standard language for designing and documenting a system in an object-oriented manner. And it's a language by which technical architect can communicate with developer and can express a design of the software. Okay, so a flowchart is a simply graphical presentation of steps. It shows steps in sequential order and is widely used in representing the flow algorithm workflow process. Typically, uh, flowchart shows the steps as boxes of various kinds and their order by connecting with the arrows. So each symbol represents some meaning. So we have to understand when we are drawing a flowchart, when we are drawing a architecture diagram. Okay. So if you see this, the first one, right, start and end. This symbol is used for starting point and ending point. Generally, we will call it as a terminal point, and this arrows, flow lines. So it will generally these arrows we will use to connect the diagrams, and we have input output diagram represents the information or data that is transmitted or received, and we have a decision symbol. So this symbol represents checkpoints to evaluate conditions for making decisions. And we have a rectangle or square box process. So this represents a process. Example, some operations. Okay, and we have database symbol. So this symbol represents the databases, and we have a person symbol. So this symbol represents actors and users or software systems. Okay, so that's all for this session, and maybe in the next session we will talk about architectural patterns. Thank you for now.